Welcome back. In this video, we're going to use distributivity to multiply binomials together. Before we begin with our mathematical work, let's just define what the heck a binomial is. A binomial is a two-term expression, and in this class, we're going to focus on linear or quadratic binomials. When reading that word, remember bi means two, that little prefix bi means two, and nomial means terms. Let's take a look at some examples to get our head around what binomials might look like. Here, this is a linear binomial because it is in the form mx plus b. M in this case is 1, b is negative 3. That's a linear binomial. It's a binomial because there are 1, 2 terms. Here's another binomial. This one's a little confusing because the variable is now m. X is no longer the variable, but it's a two-term linear expression. Finally, we could look at a quadratic binomial. This is a binomial because there are 1, 2 terms, and it's quadratic because the little square shows up. Now that we understand what the word binomial means, let's take a look at a problem in which we multiply two binomials, 1, 2, together. We start this problem by reading every word slowly out loud to ourselves. Problem 6a, let's expand each of the following products using distributivity, or FOIL. We'll come back to the idea of FOIL in just a second. Here we have the multiplication problem, m plus 5 times m minus 8. Before we do any work, we might ask ourselves, is there an equal sign in this mathematical statement? We see no equal sign, and thus we know we're going to simplify the expression. We begin our simplification by writing the entire original expression in our own handwriting. I'm going to go ahead and write specifically that multiplication in between. Many times mathematicians suppress multiplication. They don't actually write it, but I like to see it for myself. Now that we've written this expression for ourselves, I want to notice something. If we think about this whole expression over here as a single unit, notice we have a multiplication in the exact form of distributivity. M plus 5 times some quantity, well, that's A plus B times C. That is a right distributivity problem. So I can pass the multiplication by C over the addition. In other words, this would be A times C plus B times C. In this case, if I think about this entire expression as the C, I'm going to pass that multiplication over these two terms. First one would look like m times m minus 8, and the second one would look like positive 5 times m minus 8, because I distributed the multiplication on the right over that addition. That was called right distributivity. Here, now I have a chance to do left distributivity. I have a multiplication on the left, I have a subtraction in this form. I know now that this is m times m, which is m squared. Now I have m times negative 8, which would be negative 8 times m. Here I have 5 times m, which would be 5m. And then here I have 5 times negative 8, which would be negative 40. Once we've gotten to this, using both right distributivity and left distributivity twice, we can now do something called combine like terms. There are no other squared terms in this entire statement. No need to combine that one. Here we have two terms involving m, and in fact, we can combine these together by realizing if I have a minus 8m and a positive 5m, minus 8 plus 5 is minus 3m. That step right there was called combine like terms, since these two terms are alike in the fact that they both have m, and then there's no other term like 40, there's no other constants, and I'm done. I do want to call out a particular feature of using distributivity. Some of you may be aware of the idea of FOIL, which is first, outer, inner, last, the whole concept of FOIL is that I can multiply the first two terms together. If I look at this binomial, m comes first and m comes first. When I multiply those together, I get m squared. Then I do the outer terms, which is here's an outer and there's an outer. They're on the outside of those. That would be a negative 8m. Inner, those two are the inner of that particular statement. This now becomes 5m. Now I do the last two terms, which is 5 times negative 8, which is negative 40. Recognize that this line right there is that line right here. In other words, FOIL allows us to skip the work of distributivity and jump right to that expression. If FOIL and distributivity were mother and child, distributivity would be the mom, FOIL would be the child. This is a convenient algebraic step, but it really comes from distributivity. If you want to do this in my class, good, great, go for it. But I do want to say that distributivity is where that comes from. It is the source of that knowledge. And in fact, when we go back and do something called factoring, we're going to do the inverse operation of this. In any case, we have now multiplied our two binomials. M plus 5 was binomial 1, m minus 8 was binomial 2, and we found that that multiplication problem turned out to be m squared minus 3m minus 40. Let's take a look at another example to get some more practice.